This is section 4.3, part 3. In the previous sections, we talked about eliminating a variable, and we noticed that we needed to have the same coefficient, but with opposite signs. And I mentioned that we're not always going to have that happen, and here's an example of one where we don't. So what we're going to have to do is we need to transform one of these, or possibly both of these, into a new form of the equation and force that elimination to happen. One thing you may remember is that we are allowed to multiply both sides of an equation by anything as long as it's not 0. Well, you can multiply both sides by 0, but then you lose everything that's useful. Okay, so look at what we have here. We want to force one of our variables to go away. One thing that makes it a little bit easier is if you have one variable that has a 1 for a coefficient, that's the easiest thing to change. Now, you're not always going to have that, but since I have a 1 here, I can easily multiply that 1 by something to make the 3 go away. Now, think about what we want to have happen. I want to have the same coefficient, but with the opposite signs. So this is a 3 here. What I really want to have here is a -3. Okay? So what I need to do is I'm going to multiply this -3 into every single one of these. You can think of it as a big distribution. Go all the way through. Okay? So this system becomes -3x minus 12y equal to -3 times 16 would be -48. One of the most common mistakes is I see people take this and distribute it through here, but forget to do it to the other side. Remember, if we're multiplying an equation by a number, we have to do it on both sides or it's not the same thing anymore. This one already has the 3 we need, so I'm recopying it. If we've done this correctly, our x's should go away, and they do. Now I get -12y plus 5y would give me -7y is equal to -48 plus 20 would be -28. Divide both sides by a -7. And you get y is equal to 4. So now we need to do our back substitution and take this 4 and plug it in somewhere up here. It does not matter which one, and technically you can plug it in here too. Most of the time you're not going to want to do this because most of the time your numbers are going to be bigger here. Usually one of these two is going to be nicer, however you define nicer. So what I'm going to do is I like this one better because there's no coefficient on the x. So I'm going to take this 4 and I'm going to plug it in right here. X plus 4 times 4 is equal to 16. So this is x plus 16 equals 16. I want the x alone, so I'm going to subtract 16 from both sides. And I get x is equal to 0. Yes, you can have 0. Don't panic because you got a 0. I often get people who think they messed everything up because they got a 0. All this means is our answer is on the y-axis. It's the 0.04.